Hello and welcome to TidyX episode 170. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. TidyX episode 150. Thanks for checking
70.
in. 170, sorry. Thanks for checking in with us. As always, be sure to like and subscribe, drop questions, comments down below, other things you'd like to see. If you enjoy the work and you want to support the show, we do have a Patreon page, and we're grateful for anything that you'd love to donate. That said, jumping into episode 170, we're talking about tidy expressions. We're talking about tidy expressions within for loops, which is a bit tricky. So this week we were dealing with a data set that was rather large, and rather large, I'm talking like super wide, hundreds of rows, and it all followed in this cadence. And I don't know why whatever company stores their data this way, but this is how they send it to us. So this is what we got. So it was stored in this fashion, where you had a column of the athletes' names, you had a column of the seasons specific to that individual, which we can see some athletes have different observation numbers of seasons than others. And then you had hundreds of rows of stats, where it was like stat one, here's a value, and then stat one ends, so the sample size of that value. And so what we wanted to do was take that data set. So if we run the data set, we get a look at what it looks like.
Yeah, let's
Um,
load up Tidyverse for our data manipulation needs. Set a seed because we're going to be creating random values so that all y'all can recreate this data set. So let's take a quick peek at that
so
now.
yeah, so there we have this wide data set. We have our athletes, we have our seasons, we have athletes nested within different seasons. Some athletes have more seasons of observations than others. We have a stat, we have its sample size. We have another stat, we have its sample size. We have another stat, we have its other sample size. And this goes on for n number of columns, hundreds, literally hundreds of columns. So the goal was to say, hey, if we're looking at an athlete for each of the respective stats, can we weight those stats by their sample size? So we were going to use the weighted mean, and wrote this, and I said, okay, easy, we'll make a function to do this. That's easy. And then we went, hey, let's put it in a for loop so that we don't have to like retype this a million times. And that's when things got a little bit hairy because of for loops and tidy expressions.
Yeah. So let's take them through quickly how you would calculate this for like stat one and stat
Yeah,
one n.
so let's go through how we'd calculate it, and then the function that I wrote, and then Ellis will take us through the for loop, and then I'll take us through a different way to solve the problem using Tidyverse, because as most things in R, there's more than one way to solve a problem. And depending on your data, it might not always be completely aligned like this. You might have a reason to set up a for loop because you have to code a specific string to sequence along and things like that.
Yeah.
So let's
Also,
start with, oh yeah.
if you have another way to solve this, we'd actually love to hear how you have solved maybe similar problems and leave a solution down below. We'd love to hear them, and in future episodes we can maybe bring those up.
Yeah,
Yeah, like, comment down below if you have another solution for doing this.
totally, totally. Um, so uh, doing this for one is easy. We have fake dat. We're going to group by the athlete. We're going to summarize the total number of observations, which is basically just the sum of the observations within their respective stat for however many seasons the athlete is represented in the data. And then we're going to use the weighted mean function, which is provided by R, which is a handy dandy function that says, hey, take whatever value we're interested in this case, stat one, and weight it by the number of observations that we've been able to observe in stat one. So remember, we're weighting it by the different seasons, right? So it's boom, boom, right?
Yeah.
Whereas total observations is the sum of the years. So if we run this once, okay, great. We get a nice little weighted stat. Awesome. If we then make a function for this, so I said, okay, let's make a little function for this. We're going to take I don't even know that we need dat in the function because the data frame,
You should
well,
always pass stat, whatever data
we'll,
you're going to
we'll,
be
we'll pass
calculating
that,
it
yeah,
on.
rather than putting the actual name of the variable in
It
there.
makes it cleaner function wise.
Yeah, yeah. So we'll keep dat. That'll take the data frame that we're interested in, and then we have variable and n, which you can see are not quoted because they're going to be part of our tidyverse expression. We're just going to type them in normally into this function. So in this function, we basically have the exact same sequence of code that I wrote above. The difference is that the friendly people over at Tidyverse said, hey, if you're writing a function and you want to call specific columns, just go ahead and use the double curly braces and we got you covered. And so we use the double curly braces and it looks at the inputs of that function and it says, oh, you want column n from data frame dat, or you want column variable from data frame dat. So we run that function, and again, we don't need any quotes. The double curly braces observe the tidyverse expression column name, and so we say, hey, from fake dat, grab us stat1 and stat1n for sample size, and then do the same for stat4, and we get returned our data. Now, what happens if we try and throw this into a for loop and do the entire swath of columns that we have? We're going to get ourselves in some trouble.
Yeah. So if you try to pass it as a character here, like,
Yep.
which is probably how you'd have to do it, right? If you're in a for loop, you would, we'll get into how exactly you do it. But if we try to call get weight score on fake dat, but now pass two character vectors or character strings in there, we get an error. And the
Yeah.
issue is with the double curly brace, it's not expecting a character vector. It's expecting these expressions to be passed to it. So it's kind of, R does this kind of interesting thing. It's called non-standard evaluation. Don't worry too much about the details unless you're really getting into a lot of function writing and building out these crazy things. But basically what it's doing with this double embrace is, hey, don't try to evaluate the variable n, or don't try to evaluate the thing passed to variable or n. Just take that as is. Take it as that person, how that person wrote it. That's why stat1, stat1n, stat4, stat4n, we were able to pass it, and that's how it went all the way through.
And so before we get into, or Ellis walks us through how to make this work in a for loop, one thing that I did try that did not work was to use the no quote function. So if we go down to the console and we type, I was just going to say type no quote parentheses and then quote stat1 or test1. Yeah, sure, whatever you want to. So see how it gets returned stat1, and it looks like what we would normally type within that function. But if we put in nchar around that, or word class, yeah, it's a no quote. It's not the correct, sorry, yeah, number of characters didn't make sense. Class was what we want. It's not the correct type in order to make that function go.
Mm-hmm.
It's now a different type. It's still a character type, even though we just removed the quotes.
Yes,
Right? So that's a
exactly.
problem. Yeah.
So we can also just do a quick str, so stands for structure. So it's a
Yeah.
class no quote, but at the end of the day, it's still a character vector.
No, it fails. Same errors.
So it's not going to be happy with that, and the issue is because it expects a symbol or an expression to be passed to it.
Correct.
So how do we do this, and how do we set up our for loop to be able to handle all of this? So first, let's extract all of the stats that we care about from our data set, so we can just have a easily create our for loop to loop over all the stats that we care about. So we're going to take call names of fake dot, and we're going to use from stringr the str underscore subset function, where we pass a regular expression that says, okay, if it matches this pattern, we want to keep it. And what we're saying is keep when the value that gets passed to it is any characters ahead of it, but then ends with a digit, and then it's the end of the string, we want to keep those. So if we run that on off of the results of call names, we get stat1 through stat5. This might be different depending on the structure and the naming of the art or the stats inside of fake dat, but this is just a way to do it. All it really matters is we now have this stats of concern variable or object here that has all those values. So how do we actually convert the stat1 or stat1n into an expression that then we can pass on to our function? Because it kind of, now we're getting into these weird non-standard evaluation worlds. So what we can do, I'm going to skip into the for loop, tell you how it works, and then essentially what it becomes is we just wrap it inside of our for loop and everybody's happy. So let's say I is 1, So now if we pull from stats of concern, we get the stat1. And R has, ever since I think it's R version 3.6, has this handy dandy function called str to lang. And what that stands for is string to lang. So it's going to convert the string that you enter into that function into an expression, or it's actually called a name object. So let's run that. It's a name object, but essentially what it is you see it's kind of prints similarly to that no quote that Patrick had showed earlier, but this is the actual code that R is going to see and evaluate from there. And so then if we wanted to make it stat1 underscore n inside of this, because it's just a character string, we can do a paste. And so we make it stat1 n, run that, we get sample size expression, we get stat1 n. Now we get into a fun function called do.call. So do.call allows us to pass the function that we'd like to be evaluated, and then the second argument is a list where each entry is one of the arguments that's going to get weight score. Technically, we wouldn't have to name them. We could just pass it like this. But I like to name them because for my brain, it makes it easier to kind of follow what is do call doing. And so what this call looks like to R when it actually gets evaluated is much more similar to this, right? Where it get weight score, the dat is fake dat, the variable is the actual value, so stat1n here, and then n is value 2, which is a sample size expression, which is stat1 underscore n. So it converts it into the actual code that we want to be run. So we call that as do call, and then it just runs it like normal, and we get the data frame of the weighted values. We're then going to throw it into a mutate, and we're going to add the name, a column called name, and we're going to enter in the statistic that we just calculated. We're going to then drop that into a list called output, where the name is the stat again, and then we can just kind of run this. So we have our stats of concern. We pre-populate or pre-create our output list as just an empty list. We haven't pre-allocated any memory. We've just created that object now. And then for I in seek along stats of concern. So seek along stats of concern is just going to return a numeric vector with that basically seeks 1 to n number of entries in stats of concern. So kind of think of I as like an index now. We pull out I from stats of concern, so stat1, stat2, stat3, convert it into the variable, convert it into the sample size expressions, and then calculate it. Follow? Of course, it helps if I create the output. And now we get a nice list of all the outputs here. So stat4 has these values here. We can use the bind rows function to combine them all together. So now it's one big data frame. We're going to use the relocate function to move name from the very end to after the athlete column to make it the second column. And then we're going to arrange by athlete and name because we actually want to look at specific Andy stat1. This is his values. So that's how you can use a for loop and use some interesting expressions and some less commonly used functions for a normal R programmer that isn't having to build packages and deal with cases where somebody might throw something crazy at their function to handle this. But there are, of course, as Patrick mentioned earlier, another way to do this. Patrick, how would we do this in just Tidyverse?
So provided that the columns are in that convenient convention of stat and stat and they go in that order, and you're confident that they're all in that order. One way you could solve this is to take your data frame. You're going to select first the column with the value with the values that you care about. So the value columns, not the sample size columns. So here I'm saying, give me athlete season and any row that does not end with underscore n. And then I'm going to pivot that longer based on each of the stats of interest. So now athlete and season get retained as columns. and the rest of the data gets pivoted longer. And then from there, I join that to a data frame that I create that's similar, but contains only the sample size column. So here I'm selecting athlete name and now ends with _n. So that'll be all the sample size data. Again, I pivot that longer. And then I need to make that name column look exactly like the one in the column in the data frame that I'm joining to. So to do that, I use gsub and I say, hey, anytime you see _n, just get rid of it. And so now I have two data sets that have the first three columns look exactly the same, and the fourth column, which I've named in the second data set sample size, those two are different. So when I join them together, now I have this long, skinny data frame of athlete season, the value, the name of the stat, the value, and its sample size. So now I can do my group by athlete and name. And now I just run the same function that I had before at the start of this script. So we calculate the total observations, we take our weighted mean, and we get returned back to us the exact same data frame that Ellis had produced with the for loop.
Yep. So this might seem simpler, but this is because we knew the structure and were able to kind of
Yeah,
make a couple assumptions about this. But yeah, there's many different ways that you can approach this logic. And as we were doing this, I thought of a couple more ways where you could do like a pivot longer and then another pivot wider and then another pivot longer to try to do something. I'm not going to try to do that live right now.
no,
But of course, there's just with R, you're more limited by your creativity than anything,
that's right.
than actually the ability to do it. So I went kind of more on the how do I do this? So if I were to write this into a function, and how would I build this out? This is more like I've got my data set, I know its structure, I can do it this way.
Correct.
And so those are two different ways that you can calculate weighted mean using R. With that,
Awesome.
if you again call to action, if you have another way you think you can solve it, we'd love to see it down below and have some discussions between folks about what ways they like, what ways they don't like. Do you like doing these situations where you have to create your expressions or do some non-standard evaluation? Do you want to actually? I'd love to hear. Do people want to know more about non-standard evaluation? I think it's a
Yeah.
really interesting topic that R. It's kind of unique to R. Or do you? What else do you want to learn about when you're calculating these values? And with that, I think we're going to end episode 170 of TidyX. Thank you all so much for joining us for so many episodes. As always, my name's Ellis Hughes, and you can find me on various social media sites as Ellis_Hughes.
Yeah, my name is Patrick Ward. You can find me on Twitter at OSPPatrick, at tidy_explained is where the screencast lives on Twitter, or X rather. As always, like and subscribe, YouTube channel, drop the comments, questions down below. Let us know if you can solve this in a different way or if you have other questions about this. Additionally, if you enjoy the show and it's helped you and you'd like to contribute to the show, we do have a Patreon page. We're super thankful for anything that you'd like to donate.
Thank you all so much, and keep on exploring your world.